Water, which is a solid, and when I put it in the hot pan, the particles will speed up and it'll cause it to be a liquid, like this. And now it's melting.
I'll be showing you the opposite of what we just did, and this will be turning into liquid to solid. So what happens, I'll put these in the freezer, they'll get cold, and the molecules will slow down and make them form into a solid.
And it's gonna boil and then condense on the pan right here.
Okay, so now there should be condensation on the pan since it's been boiling. Okay, yeah, so all the Kool-Aid that's been boiling has condensed onto the top of the pan lid. That's what all those little water droplets are.
The Kool-Aid boiled, and now the liquid is evaporating into a gas right here. Go.
Alright, so now it's been about that. It took a lot longer than 30 minutes. It's actually been probably 3 hours now. And the liquid has finally formed into a solid, which means the molecules in the liquid were more packed together and stopped moving as much and turned into a solid.
So as I said before, with boils a lot, as the temperature, as the volume decreases, the pressure increases. And since this container isn't very rigid, eventually the pressure will become so great that it has to expand. And if I decrease the volume by so much, the pressure will increase by so much because they're inversely proportional. And the pressure will become so great that the container will have to split to allow the gas particles inside to come out. And as an opening forms, the gas inside the balloon will move to the lower pressure atmosphere that's outside the balloon. So we're going to demonstrate that by popping the balloon. Boyle's law states that a gas's volume and a gas's pressure have an inversely proportional relationship. So that means when the volume is increased, the pressure will decrease, and then what the volume is decreased, the pressure will increase. And this all occurs at constant temperature. So when I decrease the volume in this balloon, the container becomes more rigid. It becomes more taut because the pressure causes more collisions against the surface. So that's like the pressure enacting, and then since this container isn't very rigid, the volume is expanding again to compensate. But if it were a rigid container, it would just become very taut and the pressure would become very great. And then, so that's basically what Boyle's law is. And then when I release it, the volume increases again, and then the pressure comes back down because then there's more space for it to collide against the container. We're going to be demonstrating Charles' law now, which is the law that states that there's a directly proportional relationship between the volume of a gas and its temperature. So as the temperature of a gas increases, its volume increases at a constant pressure. So we're going to be using this lighter to increase the volume of the gas inside this bottle, the bottle is the container. And then we're going to use this balloon to decide whether or not the volume increases.
Now for some bloopers.
So we saw earlier, the balloon inflated because the volume increased in the container as the temperature increased. Let's see if we can do that again. Oh no! It looks like a squash. So the balloon has a constant temperature, and when you constrict the